Our planet is getting hotter, bringing dramatic consequences for both us and nature. Can humans learn to live with extreme weather?
Climate change is forcing us to adapt. We have to react and take structural precautions.
The weather is out of control worldwide.
The relationship water and people has been shifted, and those broken link needs to repair.
The clock is ticking, but there is still time for us to decide how we want to live in the future. It's a hot day in the district of Gorbitz in Dresden, Germany, which is good news for these two. Dr. Astrid Ziemann from the University of Dresden needs high temperatures to do her job.
We've often been asked what we're actually doing here, what we're looking for, where we're headed. And of course, people speculate that we're taking photos for Google or measuring radioactivity.
They are measuring something, but it's temperature. Most of these buildings were constructed in the 1980s. Extreme heat has become an issue in Gorbitz, which is home to around 21,000 people. Astrid Ziemann is a meteorologist. She hopes her work can help improve their quality of life. She finds urban heat islands on streets or squares to identify which outdoor spaces need work. One last check.
This backpack allows us to measure the heat exposure of people in an urban area. The device here measures the air temperature, wind and humidity. Up here, the solar radiation is measured. And here, heat radiation is measured from above, from the sides and also from below.
Her research can help Dresden to become more resilient to heat, something people here realized was important 20 years ago. In 2003, Europe experienced one of the hottest summers on record. An estimated 70,000 people died from heat-related causes, with around 7,600 deaths in Germany. In 2022, 60,000 people died from heat-related causes in Europe, with 8,200 deaths in Germany. These numbers show how crucial effective heat-resilient strategies have become. Astrid Ziemann has been working together with other scientists for 5 years on a government-funded heat resilience research project. While her focus is on outdoor spaces, Professor Thomas Naumann studies how buildings react to high temperatures. He's a civil engineer from the University of Applied Sciences in Dresden and tries to protect indoor spaces from overheating. Thanks to everyone here acting in concert, their efforts are paying off. Dresden is on its way to becoming a heat-resilient city. Today, Thomas Naumann will visit buildings that have already been equipped with heat protection measures. He's keen to see what the data says and hopes buildings can be made even more energy efficient in the future. Around the world, cities are being forced to take action against heat waves. For a city to be heat resilient, it should establish alarm chains to flag heat, make buildings more heat resilient for cooler indoor spaces, create green spaces which lower temperatures, and have water reserves in case of droughts. But it's not just heat that's threatening cities. Bangkok, Thailand's sprawling capital, is facing another kind of extreme weather. The metropolis often has too much water. Kotchakorn Voraarkhom grew up here. She's worried about her city. Life here used to be very different.
How people used to live with water is our identity. It used to be our road. It used to be our source of food. It used to be... We used to swim here. We used to catch fish, and this is our kitchen.
People in Bangkok used to coexist with water. Now they feel threatened by it, and for good reason.
Bangkok is one of the most rapid sinking cities in Asia. And I think some part of our city is already under sea level. And I'm a landscape architect, and I'm working towards to save my city.
The megacity was built on the floodplains of the Chao Phraya River. Water comes down from the mountains. When it also rains heavily, Bangkok can fill up like a bathtub because the water can no longer flow out to the sea. Kotchakorn Voraarkhom says Bangkok needs less gray concrete and more green plants and earth that can absorb water. The city was built on swampy ground, where the Chao Phraya River flows into the Gulf of Thailand. It used to be a small fishing village, but grew rapidly into a concrete and steel megacity, meaning most of its surfaces are sealed over. The city changed, and its water troubles have gotten worse and worse.
Only 15 minutes of rainfall, the whole city is shut down because we have a lot of runoff that we can't manage.
The consequences are often catastrophic. Around 11 million people live in the metro area of Bangkok. They regularly experience the effects of climate change firsthand. Over the past 20 years, Bangkok has seen an average of 137 water-related deaths and $7 billion in damages every year. The office of the prize-winning landscape architect lies outside the inner city. Kotchakorn Voraarkhom works across Asia and teaches at Harvard University in the US. Together with her team, she comes up with ideas for the city of tomorrow in this oasis. The office is a kind of laboratory for the future. Here, she developed her vision for a climate-resilient city. At the moment, she is focused on a very important construction project, the new government center, which is being built in northern Bangkok. Her priority is to make sure it's green and porous so that water can get through.
I think being porous is really related to Delta city like Bangkok. And many people mention about sponge city, but being porous is adding another layer of quality of water. It's not only just to hold the water, but it's also when it's at the right time, the water needs to go through it.
The fact that she was commissioned to make the building ecologically friendly is a sign of changing attitudes at government level.
Bangkok have the less green public space per capita among megacities around the world. And we have a lot of development, a lot of concrete. So the land is less porous. We have no room for water.
On the way to the site, she sees many examples of what she doesn't want to build. But can we build without any concrete? Yes, say many who argue for sustainable and environmentally friendly construction. In Kotchakorn, in Lower Bavaria, people have been using an alternative to concrete for a long time: loam, a kind of sandy clay. Georg Hofer is a loam expert. He knows almost everything about this sustainable material, such as that houses made of loam withstood extreme heat for centuries, which is just one of the material's many advantages.
My goal was always to build houses which, when they are no longer needed, can simply be plowed down. That can just be put back into the earth and left to nature without much fuss.
At first, it was difficult to get others interested in building with natural materials. Few people saw the benefits of sustainability 20 years ago. But now, he has a company with more than 20 employees and has built around 300 loam houses.
Morgen.
Today, he is sending teams to 3 different construction sites. His company builds houses, hotels, and commercial buildings.
It's working?
Yes.
All good.
The plan had been for Georg Hofer to join his father's brewery.
I took over my father's job and was head of a branch office with 15 or 16 employees. But it wasn't my calling. I'm a craftsman. I like to dig my hands into clay. It just wasn't for me.
He managed to follow his calling, and today he's an expert in modern loam construction. He spent several years developing different loam mixtures himself. He's on his way to visit a friend he's been working with for years. His friend also values building with natural materials and works with Hofer's Loam mixtures to make construction products. Stefan Egginger is an engineer who also started his own company. He's eager to show Georg Hofer his latest invention, a robot that's currently working in a converted greenhouse. The environmentally friendly machine plows the loam so that it optimally dries in the sun to be processed further.
Our aim is to make loam that's as carbon neutral as possible, to ensure that not only the materials in the finished product are eco-friendly, but that the whole production process is also sustainable. This solar loam drying is the first step.
The processing that follows is also solar-powered. Stefan Egginger sees loam as a sustainable solution for both residential and commercial construction. His company exports to half of Europe. Their various loam-based products are in demand.
More and more public buildings are being built with loam, from kindergartens to schools to administrative buildings. The use of loam in construction is on the rise and being used more every year.
One example is the supermarket company Alnatura's so-called working environment in Darmstadt. The space has room for 500 employees. It's Europe's largest office with a rammed earth facade. With sustainability becoming increasingly relevant for construction, loam has attracted the attention of several real estate developers. But many know little about this rediscovered building material. The developer of this brick building ordered loam plaster from Georg Hofer. The loam plaster is only 2 centimeters thick and bonds well with the bricks, and its benefits don't stop there. It also works like an air conditioner that doesn't need electricity.
It's very dense. 1 square meter of wall weighs around 40 kilos. So it's very good at absorbing heat. Our master builders back in the day were already using the mass to absorb energy.
But loam can do more than just store warmth. It can also keep out summer heat, optimize humidity, and it's 100% recyclable. The Loam pioneer has a clear vision for how houses should be in the future.
We need more green, more plants and more green. We need to bring nature back to the cities. I also think there could be a kind of symbiosis with loam. We need to get rid of these sealed surfaces. I think having green cities with reasonable growth and reasonable natural materials is the only way forward.
Climate change has made this type of thinking more and more urgent in the construction sector. Over in Gaubitz in Dresden, tests are already underway to see how cities can prepare. The neighborhood has become a kind of real-life laboratory. Professor Thomas Naumann is putting measuring devices in a building that already has various heat protection measures installed. He wants to know how effective the measures are. The building residents are briefed about the research project. This apartment is home to an 87-year-old woman. She's grateful that her building cooperative took steps to protect the property against heat. Naumann and his colleagues are installing 2 measuring devices that record various factors. Krista Binya is curious.
This will stay for a few weeks and then through the hot period. It's supposed to be helpful.
Here on the top, it's the temperature, here humidity, and then oxygen levels.
When I was a child, we also had hot summers, but nothing this extreme. I can do something about it by closing everything. I have those nice blinds out there, and they keep the heat out.
Industrial housing like here in Gaubitz has several weak points, thermally speaking, but there are both small and large measures that can be done to make high temperatures more bearable.
In contrast to other weather events we face, like flooding, heavy rain, or hailstorms, when it comes to heat, it's not about protecting the building, but improving people's life quality.
And the people who live here are crucial for the research as well. For the project to succeed, they have to actually use the measures. That includes putting down the blinds when it's hot outside, a custom that has long been common practice in more southern countries. Thomas Naumann finally has all the results. They show how important the team's work has been. The house to the left, with no heat protection measures installed, gets very hot. The one on the right, which has measures, stays much cooler. This is a success, but Dresden plans to do much more to become a heat-resilient city. Back in Bangkok, in the new government center, more than 2,000 people are working on the construction site. Kotchakorn Voraarkhom visits regularly. Her urban planning expertise has significantly shaped the project. For instance, there are plant holes that have been integrated into the ground that can store water and act as drains. She has long been working towards making gray cement green. In 2017, she founded the Porous City Network, which aims to insert porosity into hard-paved cities. Coastal regions in Thailand and in Malaysia have joined the network. The goal? For cities to stop being planned against water and to work with it instead. These gutters in the ground also collect rainwater, which will be stored in tanks. Like many countries in Asia, Thailand experiences extreme weather, including heat waves. The landscape architect must consider all of this in her planning. And for this particular project, she must also keep its special purpose in mind.
But we use Go because, well, it's a government center of the nation, the land of Go.
The building complex also includes a parking garage. Each floor protrudes to a different degree. The roof will be covered in vegetation, have a solar system, and a small roof garden. Rainwater will be directed so that it flows down the facade.
From the rooftop, we will catch the rain and watering the plants in the vertical. So this is not only just for car, but it's also for creating a good environment, catching rain, and also create some good atmosphere for people to walk around when they park here and then go to work.
The building project manager has arrived. He's very interested in the plans and appreciates that smart landscape architects can help create resilient and sustainable cities.
The plan is good for the climate because this will be so wonderfully green. We're grateful for the project. We'd love to see these types of greening projects all over Bangkok and across Thailand.
Kotchakorn Voraarkhom previously completed another project, which showed how important her line of work is for climate-stricken Bangkok. She rose to fame with the Chulalongkorn Centenary Park. Located in the middle of the city, this park can hold almost 4 million liters of water. It was completed in March 2017 and received global attention. The 11-hectare area has a gradual incline of 3 degrees. This means that rain flows off easily. It's then gathered in underground tanks and in a retention pond. Vegetation helps regulate the temperature and provides protection from the sun on hot days. The wetlands and water bodies have become a home for many species. And for Bangkok's inhabitants, the park is a place of rest and recreation.
My body was so stiff.
But the park is only one part of the solution.
If I say I have the park 100 times bigger than this, it's still not saving Bangkok. We need more and more and more. But the message that this park conveys is for us to live with water once again and not fear of flood, but live with it, benefit it, cherish it, celebrate it as part of our life.
As a result of man-made climate change, awareness of the value of nature in the city is growing. Nature-based solutions will become increasingly important in the future. Besides green spaces, canals are another important part of Bangkok's strategy to make the city more porous again and improve life quality for its population. Back in the day, a whole network of canals, or klongs, used to stretch through Bangkok. These were then paved over to make space for concrete buildings and asphalt streets. In her lab for the future, Kotchakorn Voraarkhom is planning to reactivate old canals. An important step, because for the city to become porous, water must be able to circulate and escape.
The canal is actually the key, but we destroyed it. But by destroying it, the existing canal is still not connected. You can see so many water gates, so many roads disconnected. So what my team and I try to do is to at least minimize all this connection and link it and combine it with a two big park of the city to let the land breathe again. And when the land can breathe, the people can enjoy its benefit.
To reimagine a city in this way is a huge endeavor. With around 60% of the world's global population living in cities, it's also hugely complicated. Kotchakorn Voraarkhom has nonetheless found a way to do it. Back in Dresden, the meteorologist Astrid Ziemann is once again looking for urban heat islands. The past summers have shown the extent to which high temperatures negatively affect life quality in Gorbitz. One part of the problem is that many of the surfaces are sealed.
Here's a spot where we can stand and it's bearable. Every station should be like this, really. If they're redoing stations or adding new ones, they should always make sure that people have shade during hot periods, either through trees, vertical green walls, or pergolas.
The research group conducted a survey which revealed that many people would like bus stops and tram stations to be cooler and have more shade.
That's exactly why we did this project, to be able to give precise measurements to urban planners, to the Office for the Environment and the Green Space Agency. You need these precise values to be able to say that these measures are worth implementing.
It takes many smart people to make a city heat resilient. Thomas Naumann is about to meet someone who uses technology to this end. Dresden's smart city manager.
Nice to see you here.
Michael Ans is an IT expert. He wants to use artificial intelligence and temperature sensors to identify urban heat islands.
A sensor here will be one of how many in Dresden?
This is one of our 300 sensors. My colleagues should be arriving shortly. They'll bring all the setup equipment with a cargo bike so that the installation is as environmentally friendly as possible.
The sensors record temperature and humidity in real time. This data is then used to create a heat map of the city.
We can't install thousands of sensors, but we can extrapolate temperature trends in the city with our 300 sensors.
Thanks to this system, heat islands can also be predicted, meaning this technology can be used to warn residents and to prevent hotspots through appropriate planning. This is also important for roads, as it's expensive to repair split asphalt or heat-warped tracks.
With this system, we'll have quantitative data for the first time about what it means financially to build here or elsewhere. If you've thought about where to build and how to build, then you can feed that into the system, and it can tell you how that will impact heat development in the city. And that input is interesting for us when we decide whether to go for option A or option B.
The smart sensor network will help make construction more robust and better adapted, so that the city becomes more heat resilient. It can also help future-proof already existing buildings. Michael Ans is interested in Naumann's data from residential buildings that haven't yet had heat protection measures added.
This is a carpet plot for indoor climate, and we start with a building with no measures yet.
The red shows how much the estate heats up when it's hot outside, room for room, strongly affecting its residents. By contrast, a building that has heat protection measures is much greener.
To a great extent, the city of tomorrow already exists today. We will be altering a lot of existing buildings. That's the most sensible strategy, both in terms of energy consumption and the economy. Climate change, whether it's heat, heavy rain, or flooding, is forcing us to adapt. We have to react and take structural precautions.
The prize-winning research project Heat Resilient City shows that there is still time to react, both in smaller cities like Dresden and in megacities around the world like Bangkok. Learning to live with extreme weather in urban environments is possible.